right. Welcome to week 2 of our online learning, and this is our third video. We had 2 last week, and this is our third video. So this is video number 3, and today we're going to be talking about circles on graphs and what an equation for a circle looks like, and some things that we can kind of do with the equation of a circle to change the circle. Now, this is what the general equation for a circle looks like. It's x squared plus y squared equals r squared. This equation, if you graph this, would give you a circle on a coordinate plane. Now, this is an example, and this tells us a couple different things about this circle that this would graph. So, for example, over here, this tells us where the circle is. If you notice, it's just a plane x and it's just a plane y being squared. There's not like x plus 1 or x minus 3 or y plus 2. So because there are no shifts with the x and y, so we'll write because no shifts with the x and y, the circle is centered at the origin. A little bit later down here, we're going to talk about how to shift a circle and move it somewhere else. But for right now, because there's no shifts, it's just x squared and y squared. Nothing is changing with that. It's just centered at the origin. This over here tells us how big the circle is going to be, what the radius is. This number that you see here is the radius squared. Since 16 is 4 squared, the radius must be 4. So this tells us the radius is 4 because 4 squared equals 16. Or you could think the square root of 16 equals 4. Either way to think about it, it tells you that the radius is 4. So let's look at these. Oh, first of all, let's graph that. So this would end up looking like centered at the origin. And if the radius is 4, it's going to go out to 4 on all the sides. So if you were to graph this circle, it would look like that on the coordinate plane. So that means that if we look at these, all 4 of these equations down here are examples of circles that are centered at the origin because there's no shifts. And here, the radius would be 3 because the square root of 9 is 3. Here, the radius would be 5 because the square root of 25 is 5. Here, the radius would be the square root of 7, which is like 2 point something, because the square root of 7 is just the square root of 7. It doesn't end up being a nice whole number. And same with this one, the square root of 2 is not a nice whole number, so we just leave it the square root of 2, which is like 1 point something. So this over here tells us the radius. Now we're going to talk about how we can translate it or shift it to somewhere else on the graph, so it's not always just centered right at the origin. So how we translate it is we just add or subtract numbers to the x and y. So for example, this used to just be x squared, but now we're going to make it x plus 2 squared. And that's going to shift it 2 units to the left or right. Now here, it used to just be y squared. Now it's y minus 3 squared. That's going to shift it 3 units up or down. Now, the thing here is that each of these shifts are actually going to send it in the opposite direction, because what you see isn't the actual shift. It's the thing that's compensating for the shift. So when you see plus 2, it's actually going to the left. When I graph this circle, it actually puts the center back here, 2 to the left. And when I see this minus 3, the center is actually up at a positive 3 because this isn't the shift. This is what's like undoing the fact that this has changed. So if you put a 3 in there, you'd get 3 minus 3 would be 0 back at the origin. So if we want this to move up 3, we'd have to make this a minus 3. It's a little bit hard to think about, but ultimately what you need to know is that whatever you see here is what's undoing the shift. It's what's compensating for it. So this is actually the opposite of what the shift is. Because this is a plus 2, that means it's moving back to negative 2. Because this is a minus 3, it's actually moving up to positive 3. It's just the opposite. Plus 2 turns into a minus 2 for the x. A minus 3 turns into a positive 3 for the y. And over here, the radius is going to be the square root of 36, which is 6. So if you were to graph this circle, it would have moved 2 to the left because it's the opposite of what you see, and then 3 up because it's the opposite of what you see. And the radius would be 6, so I tried to draw a radius of 6 around it, but it's kind of an ugly circle. Sorry about that. So let's look at each of these. Where is the center in the first one? Well, the center is going to be back at negative 3 because it's the opposite, and then down at negative 5 because it's the opposite of that one. So this circle is not centered at the origin anymore. It moved 3 to the left and 5 down, the opposite of what you would think based on what you see there. And the radius is going to be 5 because the square root of 25 is 5. Looking at this equation tells us that this circle moved to a positive 2 and down negative 4, and the radius is going to be the square root of 5. Because that's not a whole number, we can just leave it as the square root of 5. Here, it moved 1 left, 3 up, remember opposite of what you would think, and the radius, the square root of 9 is 3, so the radius would be 3. I hope this video was helpful. If you have any questions, you can just email me and I will try my best to explain it, or you can wait until our next Zoom meeting and we can talk about any questions that you have then as well. Thanks so much, and go ahead and try the practice now and see how you do. Bye.